Hello students, this is your physics class. Our last chapter was human eye. So in last lecture we have to study about human eye, its structure and functioning. So first of all we take some review related to our last topic. So first is the human eye form the image of an object. Its retina. So next one is NCERT exercise page number 108. The change in focal length of eye of a lens is caused by action of ciliary muscles. So ciliary muscles is always or also used to or help to rotate our eye lens in various direction and also focus the any point or adjust the focal length according to object position. So practice question number 1.2 on your SB3, that is the most of refraction of light entering the human eye occur at the dash. So that is outer surface of cornea. And third one is 1.3 on your SB3, write the function of each of human eye cornea. So light enter in eye through the cornea. The most of refraction of a light enter the eye occur its outer surface. And iris it control the size of pupil. And crystalline lens, it is the main feature or it is the main part of a human eye. It help to form an image on retina. So ciliary muscles is used to adjust the focal length according to object, or it also change the curvature of lens and also help to rotation of the lens. So students, what do you mean by power of accommodation of human eye? So first of all you have to watch this video. After that we have to explain what do you mean by power of accommodation of human eye.
The human eye has a convex lens. This convex eye lens forms an image of the object to be viewed on a screen called the retina. We know that in the case of image formation by a convex lens, the position of the image changes with the position of the object in front of the lens. However, in the human eye, the lens and the retina are placed at a constant distance from each other. Despite the constant distance between the lens and the screen, clear images of both nearby and faraway objects are formed. This is accomplished by the action of the ciliary muscles. The ciliary muscles change the curvature of the eyelids. When the ciliary muscles relax, the curvature of the eyelids decreases. Thus, the eyelids becomes thin and assumes a longer focal length. Similarly, when the ciliary muscles contract, the curvature of the eyelids increases. Thus, the eyelids becomes thick and assumes a shorter focal length. We can compare the curvature of the lens in the two cases. Notice that for image formation of a faraway object, the eyelids has a lesser curvature, and for the image formation of a nearby object, the eyelids has a greater curvature. As the curvature of the lens changes, its focal length also changes. The ability of the human eye to adjust the focal length of its lens using the ciliary muscles is called the power of accommodation. The human eye is said to have the power of accommodation. We can see both nearby and faraway objects clearly because of the power of accommodation. Let us understand this using an example. Rita is looking at a tree across her house. It is quite far away. Then she looks towards a window and sees a pigeon nearby. Let us compare the image formation of the faraway tree and the nearby pigeon on the retina of Ritu's eye. The light rays coming from the faraway tree are parallel to each other. They are refracted at the cornea and are incident on the convex lens in the eye. light rays towards the principal axis such that they are focused on the retina. Similarly, when divergent rays from the nearby vision are incident on the convex lens, it bends them towards the principal axis such that they are focused on the retina. Since the rays are divergent in this case, the amount of bending required to focus the image on the retina is more. Do you notice that the curvature of the eyelids is lesser for image formation of the far-away tree? However, it is greater in the case of formation of the image of the nearby vision. We know that the bending of light after refraction by a spherical lens is more for a lens with a greater curvature and hence a shorter focal length. In the human eye, it is the curvature of the lens which changes to change the amount of bending of light after refraction through the lens. The ciliary muscles change the curvature of the eyelids, so when Ritu is focusing on the faraway tree, the ciliary muscles relax to decrease the curvature of the lens. On the other hand, when she is focusing on the nearby vision, the ciliary muscles contract to increase the curvature of the lens, so that the divergent rays are focused on the retina. Have you thought why the curvature of the convex lens in the eye can be modified, but not the curvature of the convex lens in a magnifying glass? The magnifying glass is made up of glass, which can break if we try to change its shape. However, the eyelids is composed of a fibrous jelly-like material. This allows the ciliary muscles to change the curvature of the eyelids. However, there is a limit up to which the curvature of the lens can be increased, and the corresponding minimum limit below which the focal length cannot be decreased. We can do a small activity to experience this limit. Take your book in front of your eyes and move it back and forth to find the distance where you get the best vision of the text. Now, move the book closer to your eyes and observe if you feel strain in your eyes while reading when the book is really close. Let us take 10 seconds to do this. When we try to read a book by holding it very close, we feel a strain in our eyes or the text appears blurred. This is because the ciliary muscles cannot increase the curvature of the lens further to focus the image of the text on the retina, and we feel a strain in the muscles. The minimum distance at which an object must be kept from the human eye to be able to view it comfortably and distinctly is called the least distance of distinct vision, or the near point of the eye. It is the nearest distance of an object from the eye at which it can be seen clearly. For a healthy eye with normal vision, the near point is 25 cm. Similarly, the farthest distance of an object from the eye at which it can be seen clearly is called the far point of the eye. For a healthy eye with normal vision, the far point is infinity. The range of vision of the human eye is from the near point to the far point. Let us summarize what we have learned. The ability of a human eye to adjust its focal length is called the power of accommodation.
So student, in this whole video we have learned about ability of human eye, how to we adjust focal length, what is the power of accommodation of eye. Power of accommodation means how far we see and how near or closest to our eyes we see clearly. So also we read about range, we learn about what is the range of human eye. It is 25 centimeter to infinity. So there are mainly 3 points discussed in this video. You summarized and listen.
And it enables the eye to see nearby and faraway objects clearly. The range of vision of the human eye is from the near point to the far point. For a human eye with normal vision, the near point is 25 cm and the far point is infinity.
So students, this is your physics human eye chapter. We discuss later defect of vision. Today we have discussed about structure, functioning and range of human eye, and most important topic we have discussed today, that is accommodation or power of accommodation of human eye. So student, if you have any queries related to these topics, you have to text me anytime. Thank you.